So I'm going to go through the first 3 questions in this practice test. First of all, let me put my name down. I am Mr. Chow. Mr. Chow. And then let's take a look at the first question. Plot the graph of y equals to -2 bracket x plus 1 whole squared plus 8 and label the coordinate of the vertex and all intercepts. So I'm not going to use the graphics calculator for this. I'm going to show you how you can do this without using a graphics calculator by analyzing the quadratic equation. So first of all, I noticed that it is x plus 1. Which means that the axis of symmetry will be at -1. That is where my axis of symmetry is going to be because it's x plus 1, and so it has shifted 1 unit to the left. And then I'm going to take a look at values that are maybe a few behind. I'm going to do that traditional table of values. I'm going to put in maybe starting from -2, -1, 0, and then 1, and then 2, just to have a look at where those values will be. If I put in -2 into my function, then I'm just going to do all those, and then I'll be back in just a second. So once you figure out all the numbers, then you're going to plug in all of these as coordinates. So for example, -3, 0, I'm going to plot a point over there. Then I have -2, 6, which is here. And then I have -1, 8, which is 5, 6, 7, 8 there. 6, 7, 8, yep. And then we have 0, 6, and then 1, 0 again. And so these are the points, and just from having a look at these points, we can see that it's going to go down like that, and you just do that, something like that. So that's good enough, and just label each of the points. So we have our x-intercepts, okay, which is going to be 1, 0, and this is going to be -3, 0. And then we have our vertex over here, which is going to be at -1, 8. Okay, label the coordinates of the vertex, all intercepts, and we also have our y-intercept, which is at 0, 6. Okay, so moving on to question 2, complete the table. So first of all, this is not in the form of y equals 2 because we have 3y, we have a 1 as well. So we need to move the 1 over first. So we have 3y is equal to x minus 5 whole squared minus 1 minus 9 minus 8 minus 1 will be minus 9. And then we have to divide both sides by 3. So y is equal to 1/3 of x minus 5 whole squared minus 9 divided by 3 will be -3. Okay, so now we can have a look at the value. So the vertex will be at, since it is x minus 5, so it's shifted to 5 places to the right. So the vertex will be at 5 and -3 because it's -3 outside. The equation of the axis of symmetry is x is equal to 5. Remember, the vertex x value and the x equals is the same. Is it a maximum or a minimum? Well, first of all, it is positive. 1/3 is positive, so it's a U shape. So U shape means it is a minimum value, and the value will be at -3. The domain x is a subset of all real numbers, and the range will be y must be greater than or equal to -3. Let's take a look at the next one. We have our constant in front, so usually I would like to put it at the back. So let's put it in a more familiar way. Y equals to -4x squared minus 9. All I did was swap the first two terms. And now it just looks a lot easier. We have a stretch factor of 4, a reflection in the x-axis, and we have a translation of 9 units down. So did it shift left or right? No, it didn't, because there's no bracket. So the vertex will be at 0 minus 9. The equation of axis of symmetry will be at x equals to 0. It didn't shift to the left or right. Is it a maximum or a minimum? Since this is negative, so it's going to be a mountain shape, and mountain shape is going to be a maximum value, and that maximum value will be at -9, and the domain will be at x is real numbers, and y is going to be less than, since it is a maximum point, less than or equal to, and we have -9. Moving on to question 3, Determine the equation of the quadratic function with vertex at 5, 3 and passes through the point 3, negative 9. And we want to write the answer in general form. So usually, let's look at the vertex. The vertex is at 5, 3. So it's going to be in the form of y equals to a bracket of x. 5 means it shifts 5 places to the left. So it's going to be, 5 places to the right, which is going to be minus 5 whole squared. And then 3 means it is going to be plus 3. So we don't know what a is, so we need to find that out by plugging in the second point into our x and y value. So 3 is going to go into that x, and then y is going to be negative 9. And then whole squared plus 3. Okay, so negative 9 is equal to a bracket 3 minus 5 whole squared plus 3. 3 minus 5 is negative 2. Negative 2 squared is 4. So that's 4a. Okay, so let me just rewrite that as 4a plus 3. I want to move the 3 over to the other side. So that's minus 12 equals to 4a. And then I want to divide both sides by 4. So a is equal to negative 12 over 4, which is negative 3. So now that I know that a is equal to 3, then let's put it back into the equation. Y is equal to negative 3 bracket x minus 5 whole squared plus 3. We're almost there. This is the vertex form. This is the standard vertex form, but we need to put it back in general form. So what we do is we have to expand this square. So that's going to be y equals to negative 3. That's going to be x squared minus 10x plus 25 plus 3. We need to multiply the negative 3 in. So in the end, the answer is y equals to negative 3x squared. Negative 3 times negative 10 is plus 30. X negative 3 times 25 will be minus 75, and then plus 3, and let's just combine that. Y is equal to negative 3x squared plus 30x minus 72. Okay, check the next video for the next few questions.